close my face here. It doesn't matter, it's fine, I can leave it. Okay, Mr. Abubakar, where are we? Yes, we are here. Okay, guys, we're gonna study the effect of each force. First of all, uh, we're going to get okay, let's do this. Let's study each force and see what's happening. 1 minute, guys, please. Here we go. Okay, Mr. Kotso and my good guys, let's go. Okay, definitely, if we start with the force 500, we're gonna be studying 500 first on its own. 500 Newton. What is it causing on this system? It is causing a bending moment. Do you guys agree?
Yeah.
It is causing
Yes.
a bending moment. It will also cause a shear. Okay, let me remind you what we are doing. Do you guys remember what I was explaining to you last time? If you have, we all agree that this one is A, this one is B. If I can represent like this in 2D like this, do you guys agree? This is standing by the eyes of someone looking at it like this. If you are looking at it here, you stand here, you look at it like this. Do you agree that if I look like this, it means my force F here is this one? Do you agree that this force here is 500? It is simply a force acting somewhere here. Do you guys agree where there is A? This is 500. We are fine, right? Or maybe I'm not explaining it well. What's happening here? 500 here. Please do not confuse what I said last time. Last time I said we have a shear stress due to the force, and then we have the shear stress due to the object because it is rotating around the axis where the point are. In this case, we do not have that shear stress where it rotates around the axis where the point have. Usually we have it when the torque is created, and sometimes in such problem they can, usually when it's like this, in such problem the lecturer can come and add a torque going like this. He can add it if he wants, but this question he decided to make it simpler. Now what's gonna happen in this case? Your force 500 here is causing two things. It's causing a bending moment, and is also gonna cause a shear. Remember, now this is the shear due to the force, but the shear will be felt at point B. If you guys remember, we explained this. Okay, let me do it step by step. Let me start with the bending moment. Now let's agree that we all agree that this 500 is causing a bending moment, shear stress due to bending. Now the formula is what? It is rho m, let's do it like this, my over a. Is it over a? If I'm not mistaken, what's the formula
I.
again? Is it I, right?
Over I.
Okay, thank you.
Mr. Ice, you
Yes.
say something. You say shear stress. Sorry, you
I'm
say shear
listening.
stress due to bending or bending due to shear stress around or due to shear force. Sorry.
I said shear stress due to the force. If you guys remember on the previous example, we had like this, right? Something like this, if you guys remember. the one on the textbook. There was a force coming up here. The same force was creating a shear stress due to the force. The same force also made this object to rotate and create a torque. This happened because this object looked like an arm. I don't know if you see it. But this object is just a straightforward thing. It means the force that you are putting here can only create a shear force due to the force. It cannot create a torque. That's what I say. In this example, it's even easier because it's simply a bar. Do you agree that this is a bar? It's a bar. If someone come, he can bend it. If someone come, he can break it. In the other case, it was something like an arm, where one force that was here was creating a shear due to the force, where that same force also created as well a torque. That's the reason why we had two shear stress in that case. One due to the force that was this, and one due to the torque that was something like this, G R over J. Now, in this our example, we will not have this one. Why? Because in our system here, we do not have a shear due to the torque. There is no force that is causing a torque here. And what is the reason? It is because the object is simply a bar. It is not something that is having an arm or what. It's simply a straight line. In this case, if you need to have a torque, it means the question is coming, and on that question they show that, wait, this object is also rotating like this. It's been stating from the question. Therefore, you have this one. Since in our case here, there was not any statement about this showing that this thing is also turning, it means that we only have this bar here. I don't know if I'm making sense, but it's important to understand it. Where is this thing? I think it has to be somewhere somewhere on my download. So 1 minute, guys. You guys can see my screen, so it's part of the class. We are here on download. Let me open the null paper. Which chapter is this one? Did I pass it?
Oh, it's 244, I think.
244.
Page.
Where am I? 257. We're not far. We are close. Okay, yeah. I want to show you this to see what I mean. Okay, this is the example that we had. The force 20 was creating I don't know if you can see where my arrow is here. It was creating a shear due to the force at this point down here. But that same force, because it was bending the object to rotate around the axis where A and B is, it is also creating a torque. Now, the case that we are, it is this one. Similar to the first example. It is a rod. This rod cannot share this force. Do you see this force here? P. It can cause a shear due to the force, but it cannot create a torque. You see what I'm trying to say is, in such case, if the lecturer wants, he can include a torque, saying that no, this object is also having a torque, it is turning. Why? Because you have a rod, it has to be specified, it has to be said. So if it is not said, it simply means, in the case that you have, the force that you have is going to create a bending and is also going to create a shear. I don't know if I'm making sense, guys. What I'm trying to say is, in a case when you have a simple rod, it is impossible for a force to create two shear stress. By two, I mean, usually a force creates two effects. It creates a bending, it creates a shearing. But now there is an exception. There is a time that it can create a third effect, which is what? A torque. It can create a shear due to the torque. But that does not happen in such cases. Why? because this object is a simple rod. For this to happen, the question must come, like in this case here, they must show you that now this thing is turning. That's what I was trying to say. I'm gonna scroll back again to explain on the second example what happened here. The first 20, it is causing a shear stress going down here due to the force. We agree with that. Now, it is also causing a torque because when this thing is bending, it is rotating this thing around the axis where A and B is. Due to that thing is creating a torque. So this is an exception where one force was creating three things. It was creating a bending, it was creating a shear force, and it was creating a shear force due to the torque. That's what I was saying, Mr. Boubacar. Is it fine, my brother? Or is it fine for everyone?
Yeah, it is fun.
Mm.
But I have
You
connection problem here, so I'll just try to.
okay? I will share that link after the class. Now, my good people, if I may erase, I said this question is easier. When I look at this problem here, I don't see anything challenging. I do not have a torque. I do not have. I do not have. I mean, this one is straightforward. Okay, let's do it quickly because this question is easy. Now, Mr. Koso, we have 500. We all agree that 500 will create a bending, and it will also create a shear. Now, we're gonna study this thing. Let's start first easily. Now, I'm not first studying any point. What I know is this will create a bending. Let me write bending. Bending 500. So what is the formula? Shear stress is my over I. Easy as that. What is m? It is the moment, force times perpendicular distance. So in this case, we are doing the study. Ooh, this is where we have to be careful as well. We are studying around A and B. We are not going beyond A. I don't know if you see it. So if I understand well, the moment here is simply going to be 500 times 150 in meter, it is 0.15 multiplied by y. And remember, I've told you y is simply the radius. The diameter in this example is 40, so the radius is 20, which is 0.02. Now what is I? I is pi over, is it 64 over diameter to the power 4, so over 0.04 to the power 4. Now I'm just doing calculation. I am not saying at this point or what's happening. We will see what will happen just now. Now guys, if you do this, what is the answer? What is the answer, guys? Where's my calculator? What is the answer? Guys, we can't have a class. Let me check the calculator. Where is it? Oh, it is there. It is what it is. I'll be there.
Guys,
Mm.
it's
I some
11.9366 MPa.
11.93. Okay.
megapascal.
Yeah, let's
66
do it like
MPa.
this. 94
Okay.
MPa.
Eh,
Okay. Now we all agree with this bending. Now the same force 500 is also causing a shear, but now this is the formula of that shear. We say it is VQ over IB or IT. Remember I said it is the same thing. B is standing here for the thickness, which is simply the diameter. And from the previous session, I've explained to you what is Q. Q basically is what we call by a y bar. I will explain this one as well. Where a is the area of a circle, if you guys remember, pi r square over 2, and then y bar is the centroid of an half circle. I will also explain this thing why we always study an half circle, and I think I explained it last session. I will do it again here. So the centroid, it is 4r over 3 pi, if I do remember well from mechanics 1. Sorry, pi cancel pi, 2 cancel 2, so at the end of the day this one is 2 over 3 r square. So you can take this one as a clamp formula. It will always be like this, your IY bar. It will always be like this. So in this case, V stands for the force. What is the force? 500. Now, what is Q, which is IY bar? You can copy your 2 over 3. You get the same answer. R to R cube, sorry. What is R? The diameter is 40, so radius is 20, 0,2 to the power 3. Everything divided by I is pi over 6, 4, and then multiply by that, okay, 0,04 to the power 4, multiply by B. Remember, B is the thickness, which is also what we call how do we call it again? Thickness. B is the thickness. It's also it's what we call with the diameter. In this case, I will explain also why is it the diameter. So the diameter here, it is simply 0,04, if I'm not mistaken, the diameter of this circle. So if you can calculate this, you're gonna get this shear stress. Now for this section of 500, we're gonna study the effect of the bending at A and also at B for this 500 first. We're also gonna draw what what they call it, the stress. I don't know how they call it, but let me just check. But this is what the question says. It says determine the state of stress at point B and A and show the result by means of sketch. We're gonna do it as well. So what's the answer here, guys?
Hola, chao. Eh,
848.
Sorry,
848,83.
it is 848,83.
Yeah.
Is it what this guy got on his solution there? Scalas banning, scalas banning. Hey, I think I'm the one making a mistake here. I think this one is a 4. It is a 4. When you do it, you get 0,531 megapascal. Okay, this is what's happening here. Yeah, What is it next to do? You get the bending there, you get the shear there. Now can we see the effect of this bending? 500, when 500 is bending at A and B graphically, okay, let's go. Now Mr. Koto, let's look at the shear. Let's look at okay, let's look at the shear stress. I explained it last time. If you look at here, you stand here, I said you have 2 points in this case. You see A and you see B. Now this is what is happening. The force 500 is acting here. Can you see what I mean? Basically what's happening, I'm just moving this 500 here, and now I'm representing it like this in 2D so that we can see what's happening. The force, where the force is acting, it is a neutral axis. So it means along A here, 500 cannot create a stress. It can only create along the B side. That's the rule, guys. It is simple. Where my force is acting, the shear stress does not have an effect there. It has an effect on the opposite side. That is one of the reasons the shear stress of 500, let me explain. The shear stress of 500 is the shear stress that we allocate at point B. Now this thing is simply, how can I say it in the easiest way? It's a game of opposite around. I know I'm gonna be creating a shear stress where there's A, but my shear stress will only gonna have an effect at B. I know I'm gonna be creating a shear stress. Look what's happening here in this case. 300 will also create a shear stress due to this force. But do you agree that this is A, this is B? Do you guys agree that 300 in this case here, this is 300 coming down like this, it cannot create a stress along B because B is what we call a neutral axis. It can only create at A. So now it is quite simple to do the study of these two here, guys. Easy as that. The shear stress caused by this force, it is the shear stress of B. The shear stress caused by this force is the shear stress of A. So if I can put it in the simplest way, when even you face a problem like that, they go, can I say, opposite around. Does it make sense to you guys? Mr. Kozo, do you see what I'm trying to say, my brother?
Yes, yes, I hear you. I hear you.
They go in opposite way around. So now this is what happened when they said represent, let me read that question again, I don't really understand. Show the result by means of sketch plots. This is simply what they mean. Let's look at this stress here. We know that this will be the stress due to stress of B. So now how do you represent it? Basically you come around your section here, you draw it in 2D the way I did 2D. You show A, you show B. Now along, it can be below or above, it's up to you. You can show how this section of B is, you can show the section how B is going to look like this. The section where there will be effect of shear stress. This is what they mean. They simply mean calculate and show how this stress will look. Now guys, for shear stress it's quite easy guys. Before even I do the one of before I even do the one of at point B here, I know, because B is pointing down here, I already know that my shear stress will only have an effect at A. Because of that, this shear stress causing at point B here, it is simply the shear stress A. Without even doing the calculation, I can tell that no, that stress form will look like this. This is one of the reasons that I say that it is quite easy. This is about the shear stress. Now let's look at the bending. Before I go to the bending, who does not understand what I'm saying? Because I know sometimes I might feel like I'm saying it right, but it's not coming right sometimes. Please speak out for yourself. Hello? Guys, please speak out. Are you fine with what we are doing here?
Yes, we are fine, Mr. Ice.
Okay. If you are fine, I'm fine. Where's this eraser? Okay guys, let's look at the bending moment. Let's look at the bending moment. 500 is causing a bending moment. Now, how do we represent that result of a bending moment? Study is the same. Remember, whatever you do, you show your 2D shape first. You have A, you have B. Now, usually what they do here, what's happening here, you have Z axis, this is Z axis, this is Y axis. Yeah, when you look at it on 2D. So you can do this, you can extend this so that when you show your graphical of the bending, you can just look neat, just for neatness. There's no rule, it's not drawing 1 or 2. You can just show, or you can do it like this, it doesn't matter. What matters is to understand what you are doing. So now here what's happening, we are having a bending moment. Now in this case we have to know, look what happened for the shear stress. I called it shear stress B. Why do I call it shear stress B? Because 500 bending is only having the effect on B. That's the reason why it is called like this. Now for this direct stress here caused by 500, where is it having an effect? Is it having an effect at A, or is it having an effect at B? Guys, it is simple. For the bending, where it is pulling, that is where it is causing the bending. For the shear, it is the opposite way around. So in this case, this stress here will be the stress at A. Guys, you can see how it is written in your textbook. I think your textbook write like this for direct stress and like this for shear stress. So you can note this. So basically this is what's happening. So 500, you can see this force 500 is acting at point A, but you can see the effect that is having is only causing a bending. Is that a question or time? Sorry. Oh, it's time. Yeah, yeah. Is only causing a bending at A, but is causing the shear at the opposite of it. Now we know that this bending is at A. Now how do we represent the result? I don't know how to call it, the result representation of this one. Now guys, if the force oh, mm, how can I say it in the simplest way? The bending, I want to explain it in a way that you want to say something. Hello. Okay, basically what is basically happening here is it is a bending, right? But remember, this is a circle. As I'm bending, there will be an effect on the first part of the half circle. There is also gonna be an effect on the second part of the half circle. Usually, what does it mean? The first part of the half circle is basically like half motion of it, and the second part, it is usually the opposite of it. That is the reason when it comes to direct bending moment, if you look at the result of it, it's usually like this. It is usually like this, falling at the center, and then opposite like this, or it is usually like this, falling at the center, and then opposite like this. These are the two forms that you have when you do have bending moment. Now the most important thing is to know, when do we have this one and when do we have this one? That's a good question. Now how do we do it and how do we know? Mr. Koso, do you have any idea, my brother?
I think it has something to do with the axis.
Mm? Say it.
Something to do with the axis, like you see, where A and B is located.
Yeah, it has something to do like this. Now basically what's happening is just, I think there's only 4 rules to follow here, and if you get it, then you are fine, my brother. Basically what's happening here, this force is acting along A here, creating a bending, but its representation on this, on the, how do we call it again, I'm failing to get this name, its result sketched by plot. Yeah, its result sketched by plot starts from up going down like this. Now the one where the force is acting at B, where is it? This is still the same thing. The one where the force, the bending is at B, it goes from this to this. Now let me try to make it in the simplest English way and to understand what's happening. When you look at this, when you look at this in 2D, forget about X, Y, and Z here. Do we agree? If we have an object 2D like this, let's say this is X, this is Y. What does it mean? If my force is bending along the X, it means its representation will go along the Y. If my force is bending along the Y, its representation would go along the x. That is simply what it means. Now, there's two things in this topic that looks like they look like that. Now, the good thing to do, let's make it clear so that whenever we have a problem, we do not have a problem. And these two, it is the shear stress and the direct stress. Now, let's make a quick summary, guys. If you remember what I said for the shear stress, this is the shear stress. If the force is acting here, let's say here, it is A here, and this is B here, that force will, the effect of the shear stress will only be felt at point B. So it simply means the force at A here, 500, create the shear stress B. I hope that one is fine. Now, the other one is the direct stress. The direct stress, the force that is here, it creates the direct stress at the point at which it is acting. It only become opposite around when you represented it graphically. Now, my good people, before we continue, I know there is a lot of English that has been said here. Do we get what I'm saying, guys? That's the English. Do we get it, guys?
No, the
Yes.
last part.
The last partner, okay, no problem. I'm gonna repeat for you, CC. Let me check again what the time. I have 9 minutes. I can explain in 9 minutes. Okay, CC, this is what's happening. Let me erase. We have two type of stress caused in this general topic: direct and shear. The direct is caused by a bending moment. It is also caused by a direct force in case if it is exists in our system. How do we know we have a direct force? For instance, it is a force that acts straight where our axis of study is. What is this again? This will not waste my time. What is it? Okay, let's forget about this thing there. So for instance, if you had a force here, let's say going like this, whatever force it is here, this force create what we call a direct stress. Do you see it? Is acting where our point of study is, and this force, it is usually the formula of it, it is force over area. So in this our case, it does not exist, so we do not need it. It's fine. Now we are left with the direct stress caused by the bending. Now here is what I've said. For the bending, 500. Let's start with the bending. For the bending, if I have point A and B, and I have a force pulling, like this force that we have here, therefore I know that the effect of the bending will be felt at point A. So definitely I can call this one to be stress at A without even hesitating. But the same force that is pulling at A here will also cause a shear stress, but the effect of it will be felt at B. That is the reason why we say now the force that is acting at A here will simply be the shear stress at point B, because the effect of shearing is only felt at B, not at A. A becomes a neutral axis. That is the difference first. Is that one fine? And now with representation, let's see what's happening for the shear. Because this force is having an effect at B, so it simply means our representation of the shear will be a small circle. It's not even a circle. Remember, we are working with centroid, if you guys remember. It is a circle, half circle, and because we are studying an half circle, the centroid point of a half circle, it is 4r over 3 pi. If you remember how we calculated q, 4r over 3 pi. Because of that, it is that portion left there, that's where we show the stress. That is the reason when you check your solution, it is simply a part of a circle going up with stress like this. This is how we represent it. So basically what happens is the force where there is A is causing a bending at A, but it is causing a shear at B, and this is the representation of the shear. Now this is what happened. Now what is the representation of the bending? The representation of the bending, you know what, just by talking, I'm even getting a new explanation on how we can make it easier by English. The representation of our bending, I wanted to say, goes opposite the force or what. The representation of your bending start same direction as the shear created by that force. Do you guys understand when I say like that? What time is it? It's 4 minutes. Let me send a new link. Maybe it will make us time to breathe 2 minutes and we continue. Need camera help? Select notification troubleshooting. Mr. Grotso. Mr. Ndlovu, where am I? Okay, this is the null document. I think this document can justify what I'm trying to say. It can. It really can. It really can help us understand. Uncle. Seduce me, darling. Okay, meanwhile we are waiting, guys, let's have a small debate here. It will help us to understand. Okay, guys, this is what we had. Let's see what is happening here, Mr. Grotso. Do we agree that 16? Should I import this picture? I should. If it's gonna help us, we should do it. Gallery. This is the one. Yeah. Pam 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 pam. My brother, it's not even Monday you are dead. Saturday you are dead. My brother. Okay, no, it's just a quick one out of the blue, guys. Okay, now this is what's happening, Mr. Kotso and my good people. For instance, 20. 20. Do we agree that this is A, B on this case? Now 20 is coming up here. We all agree that, do we all agree that this one is the neutral axis, right? So the representation of B should be somewhere here or here. Now let's look at the solution that they got here. I can see this is where we are. Do you agree that A was coming here? I mean 20 was coming down here, but the representation is being shown on the right. What's happening here? Basically what is happening is the force is coming where there is A becomes the neutral axis, so the representation can only be where there is B. That is the reason why we do have this sign. And what does it also mean? It also means that the force 20 is simply creating a shear stress at point B. So the answer that you get here will simply gonna be the answer of point B. Now, I don't know if that's clear. What I want to get nicely is this one. Is the force that is creating a bending. In this example, what was creating a bending here? I think there are a couple of forces. This one also was creating a bending, and this one. But anyway, let's look at 16,19 here. Guys, let's look at this example. What can cause 16,19? It is this 16 force. Do we all agree that 16 here will have an effect at which point, guys? Sixteen is causing a bending effect along B. Let me bring it here so that we can see what I'm saying. This is 16. If you guys remember, when we solved this question, we say that 16 will cause a bending along B, because 16 is pushing this thing going like this, so it's bending it along B. So in this case, only B will fill. So if I can represent it like this, this is A, this is B. If I can represent it, I can say that 16 is this one, is causing an effect at B. Now look what's happening. If I have to represent it graphically, my graphical representation would be along the a-axis. It can be something like this, going like this, and then going like this, or the other way around. Why? Depending on the sign. We should see that one after as well after. That is the reason when you see the representation of 16, you see it along a line. Why? Because it is only being felt at B. I don't know how to say it in the easiest way without saying a lot of English. If B is the point that is feeling the bending, it means its representation will be at A. If A, that is the point that is feeling a bending, it means its representation will be at B. It is the same thing. Okay, it is the same thing with the shear stress. Now, the only difference is, to avoid confusion, is the only difference is the bending felt at A is the bending of A, but the representation is opposite, like the shear stress. With the shear stress acting at A, it is the 1 of B. That is the only difference. But the representation, it always go as well opposite. I don't know if that one is clear, my good people. Is it clear?
For me, it's clear eyes.
For the others, for you, say something,
It's now clear.
oh, danko. So guys, these things becomes easier and I say, if we do 2-3 example, it gets easier. Now, my good people, Andile Shangwe. Hello, Andile, how are you? Okay, guys, now you can finish this problem as easy as it is, my good people. Now, if we have to study 300, we all know that 300 it will be creating a bending. Now I know, because 300 is where there is B. There's a question someone is asking. Oh, Andile, you saying you are good and yourself? Oh, yeah, you are responding. I'm good, Andile. How is Ingrid Mambane? Now, stress reduced to 300. Same formula, my over I. But now, I know 300 is where there is B. Therefore, this one has to be the bending of...
Mr. Ice,
Yes, my brother.
did you complete the sketch they wanted there, or
To complete the sketch.
huh? Where's the final one? You were still explaining. You didn't give us
Oh, I didn't give you here. Okay.
the final one.
The final one. Okay, for the shear stress, Mr. Kotso, this is A, this is B. Therefore, the force was acting here, so if I can represent it, some people represent it here or down, it doesn't matter. But if I can represent it, I show an arc circle moving along B. No, this one is wrong. It has to move along B, something like this. Upward. Wait. So this is your answer. And guys, the answer when you do in this case, it is not half a circle. It is a small portion of a circle. It is a small portion because this is the point where the centroid is. That is the reason even on your textbook, when you see this representation, they do not put half circle, they simply show a portion, because we are studying a centroid of half a circle, which is this portion. So yeah, that this is for the first one, Mr. Koso, for the shear stress. Now, for the direct stress, Mr. Koso, you still do your same thing here. Okay, A is this side, you have B here, you can represent it down here as easy as that. I know that my bending is along this axis here, so I know it has to start up like this, and this one down like this. So you can join them the way it is joined there nicely, like this, and then like this. So you can represent values This value here, it simply means along this axis you have positive 11,94, along this axis you have negative 11,94. This is simply what they mean by that, Mr. Kotso. If we do this and we do this, you have answered the question.
Thank you.
Thank you. Now, Mr. Kotso, after answering that, we are here. Row B. I'm calling it direct stress at B because I know where there is B, that's where the force is. So, no need to worry about this one. Definitely, my moment will be 300 times 0,15 times y bar, which is the radius 0,02 over, it is basically everything like this one, but only this value is changing. So what's the answer, guys? Hey, there's Premier League, Arsenal. Man, Luo, I'm missing out. What's the answer, my good people? Oh, guys. Okay, I'm gonna copy the one that this guy wrote here. So the answer here,
7.16.
it is 7.16. Yeah. MPa. Okay, guys, you can do this and then you represent it. Let's do it like this. You have this like this, gonna be understandable. AB, Mr. Kotso. So you can draw your axis here for representation. Now, how do we represent? Easy as that. I know that B is acting down, so my line of action should be along this axis here. It's basically the opposite of this one. You don't need to show like 1,000 arrows, 2 or 3. It's just to show that it is the direct, it is the bending stress going like this. One side is positive, the other side is negative. So you can choose to say 7,16. It's up to you guys how you can represent it. And this side is minus 7,16. This is what they mean, guys, by result. What is this one? That's it. What's the moral of the story? If B is here going down, I'm moving here on representation. If A is here, I move B for representation. Easy as that. No need to worry or think much about it. So, Mr. Koso, do you believe that this one is done, right? Actually, we had an easy test last year then. It was very easy.
Yeah, it was online.
We had an easy test. But that time, online is even scary, my brother. You are doing this, given will bring you something, he doesn't even know where it comes from. You're like, man, you start doubting yourself. And you check, bro is doing business. Now, here we go. But it was an easy test. To be fair, we had a fair test, if I can be honest. It's just like at the time we couldn't really see it. Now, Mr. Kotso, for the shear stress, guys, you know, now the shear stress will be the shear stress of A. If you understand the story, if I'm here, my shear stress will have an effect of A. That's why I'm calling it shear stress of A. So now you have V, Q, I, B. Now guys, just this because we are solving and explaining. During your test, if you want to write it nicely, do you understand what I mean? When you are studying, you can know that now the force here will cause this at A. It simply means you can bring this A, this direct stress of A, and this shear stress of A on one side of the equation, and you do the same for the other one on the other side, so that, do you get what I'm saying, Mr. Koto?
I hear you.
Yeah, you can do that like that, or you can even leave it like this. Freedom, you get full marks, as long as you understand what you are doing. Now, on this case here, we have 300 times, remember it is 2 over 3 r square 0 comma, guys, it is everything that you see here, but only here you replace by 300. Let me call this everything here alpha over alpha. Okay, what I did here, I don't want to do it during the test and say that because I did it, please. I was just lazy to rewrite everything here. I called it alpha, put it alpha here so that we can have the answer. But please, I'm repeating, during your test or what you are doing, please write down, please. So if you do this, what is the shear stress, guys? What is the shear stress? This is because I lost my memory, my laptop, how do we call it, disk. I had all of these things, and guys, what's the answer? Direct stress, where is it? Where is the answer? I think it's the one of, yeah, it's the one that I see here. He got 0.318 megapascal. Okay, Mr. Kotso, if we have to represent this one, we know our story. You put A, you put B. It's up to you how you want to represent it. Now, what do we do? Where is this thing? This thing is acting where there is B here down, so the representation should be on this side. Mr. Koto, full mark. To be honest, this test was very fair. When I look at all the questions, this is one of the things that I said, even your test will not be difficult. Just don't overthink it. Don't overthink. It's gonna be what we do them. Where you don't understand, you ask. You should be ready enough to get 100 on Corsa's test. If you just redo what we are doing and understand what we are doing, Corsa is not the type of bringing trick or what. It's gonna bring something that, if you've been practicing, it will show that you were. If you haven't, it will also show that you haven't been. Yes, any other question, guys? And what I want to ask, my guys, you guys are writing about how many topics?
I think it's gonna be 3, eh?
Yeah, it's gonna be this one, it's gonna be theory of failure, and it's gonna be the one with springs. Just like the one that he sent you the solution.
Yeah, I said the next one we'll do it next time.
And guys, I think I will be honest with you. Test 1 of solid is one of the easiest. Personally, I will do what's on my side to put us ahead and understand what's going on. We can meet Monday, Tuesday, Wednesday for solid and do vibration Thursday. And I've seen like you also having some trouble with other stuff, but that one we'll see how we're gonna include it. But for now, my target is for me to make you ready at least 5 days before you write. Like this, I know I'm in peace. Like when you guys go there, you go to finish the test. You don't go to waste time you make it happen.
We can continue, Mr. Eyes.
Okay, what else? What's the next question, Mr. Klotso? Now this one is
So,
easy.
like, we are done. After that one, we are done.
I don't know. We can continue.
No, I'm saying, like, for the question, that was the final answer.
That was it, Mr. Kotso. What do you think it was? Look at your solution even. Do you know?
Oh.
Do you That's what I was saying in the beginning, Mr. Kotso. Do you know the reason why it did not even ask you to get the maximum shear stress?
Oh, why? Yeah, I know, man. There's something. Oh, he didn't ask
It
that
didn't
part,
ask
man.
you. Do you know why? Because there is no presence of a torque.
Oh, there's no
There
talk.
is no torque. And this is what I'm saying. This test was the fairest one that we could have. Look at this
Because
example.
this one we have to that one.
This one has torque. Because it has torque, under this formula that you see here, there is a torque here. Wait, let me scroll up. It's the same topic, right? I just want to show you where this formula comes from. We used to do it in diploma. This topic, this one we did it in diploma. If you didn't do it online, but those were in my class. This is the formula to get the maximum shear stress. Do you see it, Mr. Cotton? This is the one that we are using there. It is this one minus rho x and this one. This one rho xy, it is the one that we are calling the torque, the shear stress due to the torque. Do you see it, my brother?
Oh, that's why it's not included
That's why
because
it is
there's no
not
talk.
included. That's the only reason why. You see on this one, Mr. Kotso, this example here, they said calculate maximum direct and shear stress because you have a presence of a torque. So simple as that.
Oh,
Kotso can simply remove, Kosa can simply remove the torque and ask you to get shear stress, direct stress, and show these things. I don't know how he's calling it. But if you read, you know what it's asking, right? This one is calling it show the result by means of sketch plots. That is what he means by that. So if you see something like this, so it is important to read the question. So that is the reason why on this our case the question ends here. And to be honest, if you have something like this, you don't even have to spend more than 15 minutes if you practice and everything. So Mr. Konso, we had a very fair test. Where there was no talk included, you simply do this, you show this circle, you show what the full mark. And even when I'm looking at the other two question, which is this one, where is it again? Theory of failure. This one was also easy. I swear to God, when we do theory of failures, I'll just have to go through the note because I was looking at the textbook. I was like, but you sent a PDF on the group where there is this where there is the PowerPoint note, right? And guys, the thing about Koza, I think is one of the fair lecture. I won't lie to you. If you can just do what is giving you, like from the PDF, the example from the PDF, and what we do here, you cannot fail this subject. You will never fail this subject. Xavier is the same, but the thing with Xavier, he always come with something. How can I say? He always brings something new afterwards. But with Kosa, there is no surprise. If you have practiced, you get what you. If you did not practice, then it will show. And Mr. Kosa, do you remember when I say that there is no need to claim, because I'm pretty sure if this question was simply given like this during the test and we haven't done anything like this, you will think of everything that we did on that example. Am I lying?
Yes, yes, yes. So, Mr. Ice, those other ones with the curve, so those ones with the share, what,
Mm-mm.
when are we going to complete them? Because we never completed them.
Then we can complete it now, my brother.
Oh, all right. If the other people agree.
No, me, I'm fine. Are you guys good with that? Hello?
Yeah, we're fine. We
Then
can
we can
continue.
continue with them. Mr. Koto, I don't know what to do on this one. I can move it up here. Where is that thing? Oh, this is what happened when I zoom. Okay. Okay, let me bring my figure. But I don't think, I don't think I will redo again those bending and everything.
Yeah, I think we can just solve, you see? Because you explained like 2 hours last time.
But I don't remember this thing here, this solution here. I don't write it down. But let me look at the textbook if I can copy the answers. Andile, how are you? My good friend Andile. Oh my goodness. Yeah, let's finish it, Mr. Kotsu, so that we can start with new things. Nothing great was made by mistake. Okay. Uh. Okay, we had a compressive stress that was found. Compressive stress due to 16. Ah. Guys, can you see my screen?
Yes.
Do you see what's happening here?
Yeah.
What is it? I thought maybe I lost network. What is it? Don't tell me that. That's the problem with technology sometimes. Yeah, I think we are back. Oh, okay. I don't know what was that, but if we are still here, we should be fine. Okay, Mr. Grotto. Okay, guys, if we remember well, we had a compressive stress due to 16. Let me write it like this, which was 8,15 megapascal, Mr. Grotto. And then what else did we add? Um, Bending moment due to 16. It was around even which axis? Bending moment due to 16. What was it again? I see it was 65, 19 megapascal. Okay, what else did we had? We had shear force due to 20 newton, which gave us 13,58 megapascal. Guys, how many of you does not see what I'm writing, like does not, because we did it like, I think for my information, only Angile has missed my classes. This is the shear stress due to the torque, which is 40,74 megapascal. What else is missing? We have a bending moment due to 16, due to 20. 20 in this case created a bending and also created two shear stress. Shear stress due to the force, shear stress due to the torque. 20 was a lot, eh? It was too much. Okay, my good people. Now, what was the question? We want to find maximum stress at A and B. Okay, now we study at A first. If we remember, Mr. Kotso, we have to add all the direct stress at A. We had this was a compressive force because it's acting where going in the direction where there's AD. Minus 8,5 here. Now, next studying is to see between this direct stress here, which one is having an effect at A. Now, simple as that. Which one is having an effect at A? We all agreed, if you guys remember when I was explaining, 16 here is causing an effect at B here. Let me call this one rho B. Because as it is bending, only B is feeling the effect. Is pushing, B is feeling the effect. So this one is this the bending at B? What's the answer of the bending at B? Or the bending at B is this one. It is 65. Now, remember, this 20 is bending it upward. I don't know if you remember. We call certain axis like this. We say this was X. We said this was Z. We said this was Y. Okay, guys, in case of a problem where there is no axis allocated like in the previous one, freedom. You choose which one you want to put X, which one you want to put Y. But personally, I love it like this. It's just my personal choice. You can also choose yours the way you like it. We're still gonna come out to the same outcome. If you guys remember, we said that 20 is z-axis. What was the perpendicular distance? The perpendicular distance was what? Was 70. Yes. It means this object was bending upward, but if it bends upward, the guy that is feeling the effect is point A. That is the reason why here this one is rho A. So now at point A, we're gonna be having this one and then this one. 14,08 megapascal. Now this is where we got our debate, Mr. Kotso. Our debate is this one negative or positive? Now we came across, we say that this will bend like this. If I can do it like this, around the x-axis. Now if you use the right hand rule, when I use the right hand rule, I get it as positive. I don't know why the book write it negative. This is the one that is giving me negative. Okay, Mr. Kotso. Nevertheless, I'll come back with this sign here. That's the way I'm let me say struggling to get this sign right. But let's keep with the sign that they got here on the textbook, Mr. Kotso. This is the direct stress rho A, right, Mr. Kotso? When you add them here, you get, what do they get? They got minus 123,3 megapascal. Now they want maximum stress and maximum shear. Now the shear stress that is used here, remember, on this case here, the shear stress that is having an effect here, remember at A here, what am I saying? At A here, the shear stress, it is simply the shear stress due to the torque, the one that they call rho xy. Now, Mr. Code, so if we have to go to maximum shear and maximum what, we use our formula that says rho 1 2. Let me write it. Let me copy it. Okay, the formula says it is half the general formula from the textbook. Half rho x plus rho y plus minus half rho x minus rho y, everything square, plus 4 shear stress xy square. Now, Mr. Code, so in this our case we don't have rho y, and in 100% of the cases you will not have this rho y here. Now, if we have to solve it, that is the reason here when they want to solve for this, they simply have half, they only have rho x, which is minus 123. This is just a general formula, right? When they say rho x, it simply means rho e. You go plus minus half, you have, now you're gonna have one, is it 122? It's 122. You're gonna have 122 comma 23 square, because this thing will be square, remember why rho r does not exist, plus 4 shear stress of x. Okay, what's the shear stress again? Plus 4 times 40 comma 74. Remember the 40 comma 74, it is simply the shear due to the torque. That's it. Do you know why, Mr. Koso? Do you guys understand why the shear stress that we have here, it is simply the one due to the torque? Remember, 16 as it comes here, it only has an effect at point B. That is the reason why the share of 16 is not on the equation at A. We only have this one, the torque, because the torque rotates where there is A and B. Both of them, they feel it when this thing is turning. So now if we have to do it, remember it is plus minus. When you do plus 1, you get one answer. When you do plus 2, when you
Mr.
do
S, what did you write there under the square root? I can't see properly there.
this one here, hey man, that thing sometimes is a mess, my brother. Oh, I wrote it is 4 multiplied by 40 comma 74 square. It is this shear stress due to the torque. Now, Mr. Kotso, basically what you will have for maximum stress and what there, remember this one is plus minus. If you tap with your calculator with plus, you will have one answer. You will have rho 1. Let's say it is they got 12 on the textbook. Let's say you have rho 2. This is when you take a calculator, you use plus and one with minus. You need to have these two answers. It is 134, 134 um, comma 5 comma 56. Now to get the maximum shear stress, that's what they were asking there, it is simply plus minus half. There's another formula. Now you have these two stress added together. Which gives you, they got plus minus 73, plus minus 73,45 megapascal. So guys, this is what is happening. When you get this stress here, you study it at each point, you get the direct stress together, which would be your rho x in this case, and then your shear stress. You use this formula to get these two and to get the maximum. That's it, Mr. Coach. Now if you want to do at point B, you do the same thing. At point B, you're gonna have the direct stress. Remember, it is the same, this one, the compressive one. Remember, they both feel it at point N, B, because it's actually direct to them. Now what will be the bending at point B? Is gonna be this one here, this 65, this 65,19, but they got that moment negative, which I will confirm with you as well, because on my right hand rule I get it positive. Now when they do it like this, what do you get? They got minus 73. It's the same thing that we do there, comma 34. Here where come the difference, Mr. Kotsu. When it comes to the shear stress, remember, you have the shear stress, but now this is a good one. We have the shear stress due to the torque, the 40,74. Let me not put the sign at first one. And then you have the shear stress due to 16, Mr. Coulson. Remember, we say that this shear of 16 will only gonna have an effect at B. That is the reason why here. That is the reason why here for the shear of XY they have that 13 again, comma, that 13 again, comma 58. But they've got it negative and negative as well. The whole XY here that they got it as minus 54, comma 32. That was the difference, Mr. Corso. After that, you still apply this formula as written on the textbook of 1, 2. Now, what's gonna happen? You'll be having half of minus 73, comma 34. You go plus minus half. This time of minus 73, comma 34 square plus 4 multiply by, now you're going to have minus 54, comma 32. Now it's the same thing as that the first one that you did. You're gonna have two answers, 1, 2. They got row 1 to be 28,87 MEA, row 2 to be 102,21, and then for the maximum shear stress the same thing. plus minus half, add these two, plus 1 or 2, 1. They got plus minus 65, comma 54. So my good guys and people, this was the question. Now I feel like I have something that I owe you, that I even owe myself as well. It is the direction and maybe 2 more examples on this, so that I know with this topic, no matter the way that it comes, you guys can defend yourself. Andile Shangwei, my good friend Andile, I know you came a bit late, but you know I always make plan for good friend. You are my good friend. You don't let me down, so I won't let you down. We'll talk privately then.
All right, Mr. Check it out.
So I'm gonna rest today, tomorrow. Next week is gonna be hectic for us. We will push hard and harder. And what I owe you from this topic is the direction of the moment and a method to get it easier. And maybe 2 more one example or 2 to make it like official that we know this topic. I'm planning to do that on Monday, because Tuesday I want to start the new topic review, and that topic is straightforward. It doesn't have those sign and whatnot. So guys, thank you. I'll stop recording. I'm gonna